Here's y. If x is 0, what's y going to be? If you plug in 0 for x, what's y have to be?
0.
Yeah, it's going to be 0. So one of my points is 0, 0. Okay, we'll call this just 1, 2, 3, etc., up and down. All right. If x is 1, what's y going to be?
1.
Easy enough. How about if x is, I'm not going to pick 2, because that's not going to be a nice number. What's going to give me a nice number? What's the next number that will give me a nice answer for y?
3.
3 won't give me a good one. What's the square root of 3?
9.
Nope. The square root of 3 is 1 point something.
Oh, yeah. And 4.
4 will work, because what's the square root of 4?
2.
2. So if I go to 4, I go up 2. How about, what's the next one? What's the next nice number?
16.
9 is actually there, because the square root of 9 is?
3.
3. So if I go to 9, 5, 6, 7, 8, 9, it's way over here, it's going to be 3. So what's this graph look like? It looks like this. That's what this graph of y equals the square root of x is. Notice it's a sideways parabola, but it's only half of it. It's not a full sideways parabola, because then it wouldn't be a function, because you remember how functions have to pass the vertical line test? Like I shouldn't be able to draw a vertical line that goes through 2 points, because then it's not a function. Function, remember that? You remember learning about that? So that's why they don't put the plus or minus sign here. If I wanted this bottom part, that would be negative square root of x. If I wanted that, but I don't want that. There's your base graph for a square root function. So the question is, what happens when I don't know, subtract 1 on the inside? What does that do to my graph?
It subtracts 1 from the x to get the y.
So what does it do to my graph? What is this black graph going to do differently?
Go the other way.
Well, let's find out. If I plug in, when I plug this y in, if I plug in 0, what am I going to get?
The 0. Or -1.
The square root of -1. Can I do that? I can't take the square root of a -1. Not in the real numbers, at least. You'll learn about that later in another class. So I can't do that. How about when I plug in 1, what do I get?
1.
Plug it in here.
Half.
No, what's 1 minus 1?
0.
0. What's the square root of 0?
0.
0. So 1, 0 is on my graph. What about when I plug in 4?
3.
I'm going to get the square root of 3.
9.
So actually, let's not do 4. Let's do 5 instead. Let's remember how we're picking numbers nicely. Let's pick 5. What if I plug in 5 for x?
4.
I'm going to get 5 minus 1, which is 4. And what's the square root of 4?
2.
So 5, 2. 5, 2. Huh. What's happening to this graph? What do you notice about my graph? Actually, I could have plugged in 2 also, couldn't I?
Moving down.
If I plugged in 2, I would have got what? If I plug in 2 here for x, I would get 1. 2, 1. So what's this graph look like?
Shifting down.
It's not shifted down. It's shifted. What happened when I added 1 to the inside, or subtracted 1 to the inside? It shifted it right 1. See how it shifted that whole graph to the right 1? Guess what would happen if you added 1 to the inside? What do you think x plus 1 is going to do?
Move it to the left.
Yeah, it's going to move it to the left 1. Remember learning about that now? Okay, so that's what happens. Well, how about if we did this? What if I did y equals the square root of x plus 1? See how I put it on the outside? See how it's not on the inside with the radical? It's on the outside of it. Sometimes you'll see it written like that to make it more clear. What is that going to do to my graph?
Shift up or down.
Which way, up or down?
Up.
Let's test it. When I plug in 0, what do I get?
0.
Plus 1, which is 1. When I plug in 1, what do I get?
2.
I get 1 plus 1, which is 2. When I plug in 4, what do I get?
4 plus 1.
I get 4. No, I get the square root of 4, which
2
is 2, plus 1, which is
3.
3. When I plug in 9, what do I get?
3 plus 1.
Which is
4.
4. So I'm going to get this 0, 1. That's my first point. Up here is 0, comma 1. My next point is 1, comma 2. 1, comma 2. My next point is 4, comma 3. 4, comma 3. You see what I did to my graph? What did it do to my graph?
Shifted up.
Shifted it up 1. So this, adding 1 on the outside, shifts it up 1 unit. What do you think subtracting 1 on the outside does?
Shifted down.
It shifts it down 1 unit. And that's what you learned before.
Mm-hmm.
So that's what they want you to use here. They want you to use that idea, that concept to help you solve these equations and state the domain. Okay, so let's do a problem now. Y equals the square root of x plus 3. I want you to graph it and tell me the domain and range.
Okay.
Domain, range, whoops, range, and then graph. We'll put the graph in as well. So to do this problem, the key to filling in a t-chart is to pick the right numbers to go in here. Right? What do I want to pick to go in here?
1.
I want to pick something so that this thing equals what? 0, and then 1, and then 4, and then 9. Right? Because those are all what? 0, 1, 4, 9 are all perfect squares. They're all things that I can take the square roots of easily. So how do I get this to equal 0? We'll just solve this equation kind of in your head. What does x have to be?
-3.
Good, so let's make that our first thing. And if x is -3, what's y?
0.
It's the square root of 0, which is 0. Good. Let's do the next one. I want x plus 3 to be equal to 1. So what should I make x?
-2.
-2. And if x is -2, then it's the square root of 1, which is just 1. And how can I make it 4? What number do I make it to make x plus 3 equal to 4?
1.
I make it 1. And what's the square root of 4?
2.
2. And the next one is 6.
6.
And then I'll get 3. See how nice it is? You don't want to, you can choose. Remember you talked about independent variable and dependent variable? X is independent, which means you can choose it. So choose it to be a nice number. So where is the point -3, 0 at?
There.
There's -3, 0. Where's -2, 1? Right here. Where's 1, 2?
About
1, 2 is here. It's not -1, 2. It's 1, 2. Where's 6? There's 5. So 6, 3 is up here. You see what your graph looks like? Okay, now let's answer the questions. It says, what's the domain? Well, look at your graph. What's the domain of that graph? Where does it start?
-3.
It starts at -3. And does it include -3?
Yes.
Mm-hmm. And it goes to the right. So I call vertical line scan. Does that touch it? No. Does that? No, no, no. Yes. Yes, 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 yes. So where did it touch it? Starting at -3, going all the way to the right to infinity. Now for the range, I do instead of a vertical line scan, I do a horizontal line scan, starting at the bottom at -infinity. Is it going to touch it down there anywhere?
No.
No, 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 no. Yes, 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 yes. Is it ever going to stop touching it?
No.
It's never going to stop. So what's the range? Well, it started at where?
-3.
No. Started where? Where is this in my y? That's 0. Right? I'm looking at the y-axis. This is at 0. That point is 0, comma 0. So it starts at 0. So remember, your x-axis is actually called y equals 0. So it starts at 0 and it goes to positive infinity. That's my range. That's how you find domain and range. Let's try one more. Let's graph this. So again, first thing to do, we want to graph it and find the domain and range. Now hopefully you see the pattern. This is going to move your basic graph which way?
To the right one.
It's going to move it right one. This plus 2 is going to move it where?
Up 2.
Up 2. Good. And this 2 here is going to do what? We haven't talked about it yet, but what do you think it's going to do? Well, the negative is going to flip it. So instead of being like this, remember I talked about how the other one is going to be down here. So instead of being like that, it's going to reflect it, right? And then instead of this 2 is going to make it go vertically twice as fast. So if this was your normal graph like that, it would have been like this. It's twice as fat. It's stretched vertically, okay? But to be safe, we're going to just go ahead and make our t-chart over here because we've been doing that anyway. And let's pick our numbers nicely. So what values am I going to pick for x? Remember, I want this to be what?
0.
I want it to be 0. How am I going to make it 0?
Put in 0 in for x.
Nope, not put in 0. If I put 0 in, I'll get that whole thing. Yeah, I want it to be positive 1. And then I'll get 0, but this is 0, but I still have plus 2, right? So my answer is 1, 2. You follow?
Mm-hmm.
How about the next one? I want this whole thing to be now not 0, but now let's make it 1. So what does x have to be? 2. And if x is 2, I'll do the work over here. It's going to be negative 2 times the square root of 1 plus 2. And what does that all equal? Negative 2 times the square root of 1 is negative 2, plus 2 is 0. So my point is going to be 2, 0. So let's put that in here. There's my second point. My first point was 1, 2. 1, 2 is up there. Whoops. There's my first point, 1, 2. There's my second point. Now let's pick a third point. What do we want to this be? We had just had it equal 0, then we had it equal 1. What's the next good perfect square?
2.
4. And so what does x have to be for that to be 4?
5.
5. So if I plug 5 in for x, I'm picking my x value strategically. If I plug that in for x, it's going to be negative 2 times the square root of 4 plus 2. And what's the square root of 4?
2.
2. What's 2 times negative 2?
Negative 4.
Negative 4 plus 2 is?
Negative 2.
Negative 2. So 5, negative 2. 1, 2, 3, 4, 5, negative 2 is right there. And can I see what's going to happen to it?
Mm-hmm.
It started here, right? So it's going to go like this. See how this 2 made it go wider? Normally it would have only gone like this. Right? But because of that 2, the factor of 2, it made it wider. In other words, it stretched it vertically. Okay, so there's my graph. Now let's find the domain. What's the domain going to equal? And then we'll find the range also. What's the domain? Remember, scan. Scan.
Positive 2.
Not 2. It starts here.
All right.
So it's positive 1. It starts at 1, and it goes forever to the right. So 1, infinity. Got how I did that?
Mm-hmm.
Tell me what the range is going to be. Is it touching down here?
No. Negative 2.
Hold on. Is it touching down here?
No.
Is it going to touch the graph?
Yes.
Yes, it will. Will it touch the graph at negative a billion?
No.
Yes, it will. Because this arrow is going down. It's going down as far down as you need it to go. Where will it not touch?
Positive.
It will not touch when it gets above what?
Positive 2.
When it gets above 2, it won't touch. So how do I write that in interval notation?
Positive 2, negative infinity.
So we're actually going to start at negative infinity. So we always